It's alive! Welcome back. This is my second panel, as you might have seen on the previous video. So let's go through what I managed to build here. Yes, there is definitely room for improvement. It's not finished yet, as you can see, purely because this EVD stepper valve controller, it's proving to be a bit difficult, for me anyway, to make it work in order to adjust the temperatures or the pressures using potentiometers. So yeah, this is still under work, but what I want to do with this one, I will talk about it in short while. So let's just go through a few things. I've used a Danfoss back controller, an EKC 531B, which can deal up to 10 compressors, and obviously recognizes the safety trips on the compressor side. It's got 0 to 10 volt output for the condenser fans, plus many other features which we will explore in future videos. Next, we have 8 safety switches, so these will simulate if a compressor is stripped. So we have 8 because I decided to use 8 compressors. We have 4 condenser fans. We have 3 safety switches. They are not compressor trips, but they can be HPLP shutdown, they can be a low liquid level, they can be anything we want it to be, depending on what the controller can offer. Next, we have a 24 volt transformer. The reason why I had to use one is because the safety circuit for our compressor and the feedback to the controller is on 24 volts. So each safety circuit is protected by its own fuse. Next, we have compressor relays. So when the controller wants to call for a compressor, it will energize relay number 1, which in turn will send power to the contactor, and then in turn it will run the compressor. So our contactor and our compressor here is being simulated by just a simple LED light. Now you might count the relays and see I have 10, not 8. Compressor number 1 has 2 relays because one relay is a safety switch relay and the other one is just a compressor relay. But because it was too impractical for me to keep adding relays, I decided to use for compressor number 2 up to compressor number 8 just a normal relay and bypass the safety relay. I just wanted to show that if the safety circuit is healthy, that in turn will energize the safety relay, which is a condition to operate the compressor relay that in turn will energize the contactor and then give power to the compressor. So that's the reason for compressor number 1. It's just a different way of wiring. I chose for compressor number 1 to use 2 relays, one for the safety circuit and one for the running of the compressor. So how many relays do I have? So I have 4, 6, 8, 9. Yes, so that's compressor number 1 and so on. We have a timer relay, purely because if you have a low liquid level alarm, for example, you want to wait for a minute or 2 or however long you want to set that in order to make sure that it is an actual alarm, because sometimes things can happen a bit too quickly and it might generate a false alarm. So I decided to put a timer relay. It's quite common on bigger systems, especially on packs, to have timer relays in there. And here we have a condenser fan relay, but for the setup I chose, it's not being used because this controller, unfortunately, only gives the signal to the condenser fans, 0 to 10 volt signal I'm referring to. It does not run the condenser fans the way we run the compressors. It's just the way this controller is. So, but maybe in the future, if we do have a controller which can operate condenser fans as well in sequential mode, for example, then this relay will have to be in place. And moving on, we have a 12 volt DC transformer. It's because these fans, they operate, they run at 10 volts. So I had to use a DC transformer in order to run these 4 fans. We have our display, suction pressure and discharge pressure. We have our EVD twin controller. These controllers can operate a stepper valve, just like this one. Now you might see another transformer here, and you might wonder why haven't you used only one transformer. Well, I did initially, and I made a big mistake, because what ended up happening was this transformer was overheating. And I was a bit baffled. I said, why is that happening? There should be enough for one transformer to run all of this, including that one. Well, I couldn't be more wrong. It's because this controller, it does say on the manual, which is there for those who want to read all of it, and unfortunately it wasn't me when I first started it. This controller can pull 2.4 amps, for example. I think I'm right, it's 2.4 amps. But this transformer is rated at 1.3 amps, if I remember that correctly. Yes. Yeah, around 1.3 amps. So I had to put a second transformer, wire it in parallel in order to increase the amperage, keep the same voltage, so I can run this one as well. So it was my mistake. So that's why now I have 2 transformers instead of 1. So I'm still trying to commission this one. It's proving to be rather difficult to get this controller to recognize the potentiometers as temperature probes and pressure transducers. They share some connections on the actual wiring between the temperature and the pressure. For example, S1 and S2, and then the next set would be S3 and S4. And I'm still working on this. So yeah, but I want to commission this and see inside here the way the valve opens and closes, or the percentage of opening and closing, which is the clue is in the name. It's trying to modulate the amount of refrigerant that goes through a system, but I want to be able to see it, because I find it quite interesting when you can physically see what is going on. So I'm still working on this, but yeah, so let's just give it a quick test, show you around, as they say, and we shall move to my second video. Here we are. It's alive. Silly me. Yes, so my pressure is 4.2 bar. I'm just going straight to it. My discharge, so my suction is 4.1, my discharge is 16.5 bar. These are my potentiometers, as you've seen them on my first panel. We have LT, pressure transducer, HT, discharge, and 2 more for probes, but they're not wired. So these are extras in case I need them in the future. This transducer acts like a fan speed controller, because now you have fans which run faster or slower according to a 0 to 10 volt signal. So I use that in order to simulate it. So you can see, if I move that, there we go. Being a bit temperamental. Well, you know, worky. No, doesn't want to work with me. So if I were to simulate a major fault with the pack, like a HP LP shutdown, which I think is this one, or this switch shuts down the pack, it senses that there's a major fault. I should say extremely high pressure. I turn it back, it will start bringing the compressors one by one. This one still does not want to work.